Hey everyone, Radhe Radhe. My name is Anand Pasha and today we'll be learning about the Cilium Egress Gateway API. In the last lecture, we tried to learn about the Cilium Ingress Gateway APIs, and before that, we tried to learn about the Gateway APIs. If you doesn't know about it, then you can head on to my previous lectures and the videos that I uploaded about the Gateway APIs, API, and why do we need the Gateway API at all, and how is it a lot more better than the Ingress Gateway API at first instance. So, in this lecture, we'll try to learn about the Cilium Egress Gateway APIs. Earlier, for the networking usage, there weren't much difficulties when the solution architects and the network engineers used to design the whole architecture of our applications. It was all about the traffic routing to enhance the security, networking, as well as the connectivity between the different services and the parts of your architecture and the application that you are hosting at the moment. But then later on, when the cloud revolution came and the Kubernetes, AWS, and various other services also came into the existence, a lot more complexity was actually being added onto the infrastructure. That's why a lot more, the roles have been coming up as the platform engineers and various other roles as well. So that's why to handle that much complexity, and also at that time all the networking and the connectivity used to handle on the basis of the static IP addresses that were being provided to the different devices or even the different pods in their system. But then later on, with the introduction of cloud, we dynamic IPs also was introduced in our systems. Dynamic IPs, and also with the Kubernetes being introduced, the routing as well as the changing of the IP addresses depending upon the various different resources of our architecture, it made up the things a lot more complex as compared to the earlier stage of our development. So that's why the gateway APIs or the egress gateway APIs are really handy, a lot more beneficial when it comes to handling these routing and the traffic management problems as well. So the Cilium Egress Gateway API, let's try to understand about the Cilium Gateway Egress Gateway API. Cilium implements the controls. It controls and functions on the basis of the layer 3 and layer 4 of our the whole network, which directly communicates along with the Linux kernel using the eBPF. So it's a lot more easier as well as implementable to your operating system. It's a more it can get imposed in the future, as we have seen in the Cilium Ingress Gateway API. They were working really hard, making up a lot of efforts to make it an inbuilt feature of the Linux kernel itself, so that a lot more proxies aren't being introduced for each and every particular resource that has been built or been deployed into your Kubernetes architecture. So the Cilium Egress Gateway API works on the basis of the layer 4 and layer 3 of a network, directly communicates along with the Linux kernel using the eBPF. It changes by specifying which node you have to reserve for handling the egress requests, for handling any particular request of the traffic that has been coming from the external server, from the external the external site or the external server that has been built from to manage the air traffic for your architecture, for your application. um, Traffic from these pods are being sourced or donated to the IP addresses or the nodes on which they are being scheduled, and then the IP address of that node would be used by our Kubernetes cluster to make up the connection with the external server that is being hosted somewhere in the network, between a lot more other the vulnerabilities and various other problems as well. If and that's why the security and various other things have been implemented, so that our the whole system of the Ingress Gateway APIs and the traffic management and the orchestration has been enhanced a lot. So the Cilium Egress Gateway requires the replacement of the Cilium's queue proxy replacement. Alright. Also, as well as also the egress gateway enables connectivity between the Kubernetes clusters and the traditional firewalls. If a node becomes unavailable, then the Cilium reroutes the traffic by another gateway dynamically. It's an amazing feature. Also, no sidecars are required in this particular egress gateway API, so that's why it's the latencies are a lot lower as compared to the earlier stage, and the CPU usage is also lesser comparably. That's why the sustainability is also higher, and the overhead computational power would be lesser. So let's now try to understand how do we perform all of these actions, and then later on we'll try to implement all of these particular features by our lab session as well. Right, so in the how to, or let's try to understand how do we do this particular, implementing the egress gateway API, Cillium's egress gateway API onto our application. First of all, amongst all the particular nodes that has been deployed onto our architecture, we have to select any particular node that will be handling our egress. We can choose two or even more nodes from our architecture depending upon the the requirement of our application. For my case, let's try to pick any two particular nodes. I've been taking this example from the documentation of Cillium Egress Gateway API. You can also read that. I'll link it in my description as well. Alright, so let's try to select any two particular nodes from our the workload or our cluster, and then the selected egress gateway APIs I have to be attached to the Docker, the Docker network that has been called as the kind. If you doesn't know about the kind, then kind is stands for the Kubernetes in Docker. So it's a lot more efficient and a lot more easier to handle your Kubernetes cluster if for and managing your Docker network as well. So that's why we'll be using kind with a specific particular the IP range as well, and then we'll try to add a dummy interface to our application, to our both the nodes that has been reserved for handling the egress request, for handling the egress gateway API. So, in our case, we'll try to take the net 0 and the int 0. Both of these will try to dynamically allot them while installing the Cillium. And the next step is also of installing Cillium. So we'll try to install Cillium, as well as also, as I told earlier, Cillium Egress Gateway API usually works on the layer 3 as well as on the layer 4 of our networking or the OSI model, because the layer 7 of the layer 7 won't be completed. It will stay incomplete when we are using or been working along with the Egress Gateway API. So that's why we'll try to disable the the layer 7 of our Cillium. And the Cillium proxy will also get replaced by to use the Cillium Egress Gateway APIs, and we'll try to attach or deploy two interfaces or to manage the outbound traffic. The interfaces are being deployed and being attached to our the nodes so that they can handle the outbound traffic that has been requested or that has been flowing into our architecture to manage the security and the traffic management policies. And then we will try to handle the traffic from the pod inside the Kubernetes cluster, because it's the external environment, and thus the source IP address will be used for our nodes to handle the traffic. And then the next particular step would be to build an external server to which our the communication or the connection will be built and being established with our application, with our core application or the cluster that we have deployed at the moment, and then link along with the Docker network kind as well. So yeah, and then add the pollers or the containers in our default namespace through which the traffic will flow, depending upon the in which namespace or depending upon the various different labels that we have set earlier, and then we will going to set according to our egress policy definition file as well. So, and obviously, so the next the step would be to define or deploy a definition file for our egress network policies. So yeah, let's try to